Hello, I'm Orville Ray Scott, founder and CEO of the Student and Professor Technology Company. Here at SPTC, we are dedicated to bringing the most advanced technology to academic laboratories around the world. We understand the concerns that both students and professors have when trying to research and publish the ideas of tomorrow. Now for you professors, we know that you struggle with the constant demand to publish. We also know that you are far more successful with bright, motivated graduate students. However, graduate students today have many weaknesses and a constant need for attention. And that is why we have developed one simple solution. Replace them with computers. Computers are able to work 24 hours a day. That is 3 hours more a day than your average graduate student. And once you turn the graduate student computer on, they never bother you again. And even though they work 24 hours a day, they have no need for food or for personal hygiene. Therefore, your laboratory remains clean and fresh. Now, for you graduate students, we know that many of you suffer while your advisor is on yet another sabbatical to Hawaii to research what he calls the significant relationship between ocean tides and human behavior. However, no one has still seen data on this research. Isn't it about time that you replace your advisor with something that actually has a memory? Yes, students, you can also replace your professor with computers. And these replacement computers come with unlimited funding, prompt thesis editing, and guaranteed tenure. So if you are interested in one of our replacement computers, contact us and we will replace your graduate student or professor immediately. SPTC will guarantee your satisfaction.
Technology certainly has come a long way over the years. However, I think we're a long way from replacing our students and professors with computers. However, computers are important in biomechanics today. Many researchers use finite element analysis to predict the mechanics of human behavior in situations that would otherwise be impossible to test. The first step of finite element analysis, or FEA, is to duplicate the geometry of the specimen in the computer. A common approach taken is to use X-ray CT. The geometry is then separated into thousands or even millions of smaller pieces called finite elements. Each finite element is relatively easy to analyze on its own, especially using computers. After the geometry is duplicated in the computer, the next step is to add the material behavior and boundary conditions to the model so that the computer can accurately model the physical behavior of the body. With this information, the computer software can determine a solution. But the most important step is that those solutions need to be validated by comparing against what is already known about the problem based on previously obtained experimental data. After the model has been validated, we can use it to answer the questions that can't be answered by direct experiments. For example, we can use this finite element model of the spine to see how the behavior of the low back would change as a result of ligament injury, disc degeneration, or following surgical treatment. Finite element analysis is a growing field and one that I'm excited to be working in. Well, that is until I get replaced by a computer.